Okay.
Josh, I think you're still, I can't hear you, Josh. No, nothing yet. You can try typing it into the chat box.
That could be a case of not having enabled the audio through computer at the beginning. That's a common thing that happens. So maybe Josh can get that straightened out. Yeah, I have one comment actually, and that is one of the really good things about this is that all the groups showed improvement.
Yeah, I mean, that's not surprising because all of the students in these three groups took an astronomy class. So you would expect there to be, I mean, you're hoping that your instructors are not so terrible that you would see negative gains in the students. And so it's not surprising that they all show improvements. And in fact, if we go back to the excuse me, for some reason there's some weird audio coming through the loudspeakers here. So, but if you actually look at all of our other papers, so we've published on 3 different topics involving, and where we look at how students do in the planetarium versus students in the classroom. And we actually see very similar results in the sense that the students in the dome for each of these topics do better than the students in the classroom, and their retention over time also tends to be better, meaning by the end of the semester, they also, the group 3 students have higher scores compared to their pre-test scores than the group 2 students. And also, unfortunately, in all of our papers, our control group, group 1, also all have somewhat anomalous results that we can't really explain. So there's something really weird about our control group, and unfortunately, we don't have the data to help us figure out why they're so weird.
Well, don't you think that it's just that, you know, people have varying interests in space science, and so if you just stick a bunch of people in a classroom, some of them will be interested, some of them won't, and you'll have this wide range of abilities, and because of the interest, or vice versa.
Yeah, that could be the case, but it's not something that we were able to test. And you know, unfortunately, we actually we might have some data about some student attitudes, but they weren't specifically about astronomy. So that's something perhaps to look at. And let's see, I think Josh from the Morrison did type in a question. The importance of change over time versus change in perspective due to position. Could 2D animation score a similar boost? And this study can't really answer that question, just because what we did was to, you know, all of the students that experience visualizations, whether in the classroom or in the dome, saw the same set of visuals where, you know, so they experienced the changes in perspectives or frames of reference, and they also saw the Earth go through time and seeing how seasons are a reflection of the varying orientation of the sun's light. So everyone got the same types of presentations, and we weren't in our questioning trying to tease out the effects of one part of the presentation versus another. But there have been other studies that have looked at the use of an iPad running a solar system app, where, and this is by Schneps et al. 2014. Schneps is spelled S-C-H-N-E-P-S. I'll just type it into the chat window. And what they were able to show was that students who were playing around with the iPad and actually using the pinch to zoom feature had a much better understanding of the topics that they were trying to get them to understand. So here is one example where, in this case, an interactive visualization on a handheld tablet was shown to be really successful. So we have evidence that these types of animations can be very productive. All right, and then Andy asks, how much actual instruction time took place? Was instruction time the same for all three groups? Yes, we tried to make sure that we had the same amount of instruction time, although there were variations, because what happens is that when you're trying to get a group loaded onto a bus, and the museum is about 2.5, 3 miles from the school, there are always inevitably some delays at one point or another. And so, but we did try to have presentations that were as close in time as possible. And if anyone suffered with the lack of time, it was actually the groups who went to the dome, just because sometimes they lost a few minutes at the beginning due to bus mishaps. The other thing that we try to keep constant, at least for group one, was that the materials used in group one were extremely traditional, meaning they were 3D models used in the classroom, so not digital models, but actual physical models, and traditional static 2D images and pictures and slides and diagrams. And so even though at the time there were plenty of animations that were found on the multimedia CD-ROM that was attached to the textbook, the instructors explicitly did not show those animations in class. So the group one classes were all very old school. Now, of course, that doesn't stop students from putting in the CD-ROM themselves and looking at those animations. So there's nothing to stop them from doing that, but we try to keep the situations between group one and the other two groups as separate as possible.
Toshi put something in the chat window, but I just wanted to say that on my screen I have I had 14 participants when we first started, and when you ended your presentation formally, we still had 14 participants.
Right.
That's very good. So we probably have time. You might have time for a couple more questions.
Yeah. So it looks like Toshi has a question about the flat-cornered versus the different Earth mental models. So how were those collected? There have been lots of different studies that have been done where you see a lot of the same mental models show up in different populations of students from all around the world. So I can't remember exactly which ones those are pulled from, but Stella Wozniacki is the one who pioneered that research. And so she's done work both in her native country of Greece as well as in the United States that show this. And generally what she initially started doing was to interview students, but over time as they did more studies, and not only with her group but from other teams, they got very similar results by expanding by including drawings, and then eventually having students model in clay just to make sure they don't, they cover all their bases.
Ka Chun, can you really quickly, you said you were going to type in the study for interactive animations into the chat box. Did you do that?
Yeah, I typed in the name of the author, but let me see.
Oh, okay.
I can actually.
I didn't make it. I wonder if it was a private done.
Yeah, because I'm really looking into stuff like that, because NASA Eyes is a product that's interactive, but I couldn't find any literature about it being used in museums or in classrooms.
Let's see. I'm gonna go back to. I'm just gonna put the paper up, just so you can see it. Let me.
Thanks. And then while you're doing that, I had the same question as Andy of, did the classroom instruction include, actual activities of kinesthetic models?
No,
No.
so we didn't do any sort of kinesthetic activities. We actually only had 4 classes that were devoted to these 7 topics. And so these were, about roughly an hour-long class. And so that meant, and remember what I said at the beginning, these classes covered solar systems and stars and galaxies. So they covered all of astronomy, which is normally done in most schools in 2 classes. And as a result, we didn't have, we kind of had to speed through the topics. And so for the planetarium visits, and for the classroom visualization, what the students saw were actually, we taught 2 different topics back to back for each class. And there were 4 classes total in which we did this. So in the end, it actually wasn't that much time that was spent in going over this material. And so we didn't have time to have kinesthetic activities. I'm trying to remember if the classes had a moon lab where they were supposed to go out and look at the moon. That's something that I would have to look up, but in any case, that doesn't affect a study on the seasons. So in the end, what was kind of remarkable is that you're looking at let's say half an hour, 25 minutes to 30 minutes worth of instruction on the seasons in a traditional classroom where you're using all of the elements that a traditional instructor would use. And these classes did not really have a lot of the important interactive elements that you see that's been shown to be really successful in astronomy classes, undergraduate classes today. So the instructors didn't do things like think, pair, share, or a lot of the other exercises that have been shown to be really effective. So what we really were studying was the effect of visualizations in a traditional, not very interactive classroom.
And would you mind going back to that slide of the results, of the quiz results?
Yeah.
And you said there was a pre-quiz too. Oh, that's together.
Yeah. So,
okay.
So what we're looking at is basically the differences in quiz results, because we're interested in any learning gains that the students might have. But the paper does have a table showing what the average results are for each sets of quizzes before we subtracted them. So this is only a difference plot.
And I do really find it interesting that the control group has, like we said, that really wide range of where some students actually outperformed group 3 and 2.
That's not quite what it says.
Right.
That's just an error bar.
Okay.
We don't know exactly.
But, the numbers could be real, but it could also mean that, it's really hard to say. I mean, you wonder whether there was cheating going on with one set of students. But I've actually looked at some of trying to understand where these students were in these 3 classes, and they're not, they don't seem to be clustered in any way. So, it could be just an odd statistical quirk where, for some reason, the students that we had just ended up getting those answers at the end. Another check would be to see how well they did on the other test questions that didn't have to do with the subjects that we're focused on. So that's something that I haven't done. But obviously, the best way to handle this would be to get more data and try to drive down the noise.
Well, the reason I find it so interesting is because something that interests me is the effect of relieving students' cognitive load when learning versus making students expend mental effort to learn something. Because I've read some studies that say that that the harder the kids actually have to work in their own head to understand the concept, the better they learn it. And then there are other studies that say that, you know, making it easier for them to learn it, reducing that cognitive load helps them learn it. So that balance of, you know, you want them to pay attention, you want them to try, but you don't want to make it overly difficult for them is an interesting concept for my teaching.
Mm-hmm. And I've heard, I haven't really gone through those studies, but I've heard of them and I've seen some of the abstracts. And yes, it is really interesting that there is a movement to study, you know, how you can have effective instruction by making the students sweat or work hard, and you know, whether that could have been done here, that's an open question. You know, especially considering that the instructors were speeding through a lot of this content. I mean, if you think about generally how much content shows up in astronomy 101 classes, and there has been a movement in recent years to push back on. I mean, if you've ever looked at an undergraduate textbook, they're enormous nowadays, and they cover a huge range of topics. But there's been a movement now for people to pare back on the number of topics that they teach, at least in formal education at the undergraduate level, just because it's really impossible for any sort of deep learning to take place when you're speeding through these topics. And so it might make sense for you know, for you to make students work hard for their understanding if they don't have to be tested on lots of different topics, but they can focus instead on far fewer topics, but learn them more deeply than they would otherwise.
Yeah, and I would just propose like that, for example, that group one really had to expend mental effort. So the people who were interested in it processed it more because they didn't have any visualizations. Mm-hmm. They had to work it all in their own head. And so some kids learned it better than others just because of that. Whereas group 2 and 3, they had that reduced cognitive load. If they didn't have to picture it in their head, they could see it. But that means they also didn't expend that much mental effort to do it. So
yeah,
I think that's interesting.
Yeah, that could definitely be correct. That's a great perspective, Jeff. I never thought of that before. Thank you for that. So let's see. Just looking at so maybe I'll just answer the remaining questions that are in the chat window, and then we can end this presentation. Josh Roberts says, "Do kids still know what CDs are?" Well, they probably did 10 years ago.
That was a joke. That was
yeah. I know it was a joke. Reason for my question regarding time of instructions that used to spending far less time with school groups in the planetarium. You have groups for longer. You can use kinesthetic model, and that found that students and teachers found this useful. And there have been educational research work done on kinesthetic astronomy, and so that's been shown to be effective. So I'm not surprised. And Toshi asks, what was the time lag for the post-assessment? So most of these topics that we were studying, eclipses, seasons, phases of the moon, these are all topics taught right at the beginning of the semester. And so, you know, we had the students going to the dome in the first, you know, I think by weeks 3 or 4 at the latest. And so the contemporaneous quizzes were done that same week as their week of instruction, whether it's in the dome or in the classroom. The pre-tests were done on the first day of class. So that means you had a lag of a few weeks between the pre and the contemporaneous tests. And then the post tests were done at the very end of the semester, basically the final. So that's a couple months later.
Okay, well, I think we need another round of applause for Ka Chun. Thank you for launching our seminar series. Thank you.
Thanks, everyone.
Thank you.
was useful.
Yeah, Ka Chun?
Mm-hmm.
Just curious, are you aware of the program that Pat Rife did back in 2014, I believe, at Rice University? I mean, she actually did something very similar to what you came up with, and did I think she used the same students in a classroom, taught the same lesson in the same amount of time, brought them to the planetarium, and the end results were that those that learned in the immersive environment actually did better on their quizzes than those in the classroom.
Mm-hmm. Yeah. Pat did have very similar results, and I've looked at all of the work that she's done along with the Houston Museum of Nature and Science group, and they focus on school children. I think mostly middle school kids that go to the museum, or they have a geodome or a portable dome that's brought out to the schools. And what's nice about their work is that they are able to look at the test scores of thousands of kids, and they do see a difference between the classroom and the dome group, as you said, John. But from what I recall, looking at their papers, they don't hazard any guesses as to what specifically causes the difference between the school and classroom groups, or classroom and dome groups, other than the fact that one is more immersive than the next. But yeah, they've done some really nice work over the years.
Yeah, I'm just glad to see other folks doing similar research on that, because I think it's really needs to be done.
Mm-hmm.
I think at this point, I'm going to stop recording. That's the official end of the question and answer. And for the last part of our meeting, which for the last few minutes, we could have a little bit of a debrief, and Ka Chun, you're certainly welcome to stay as long as you can. I know you have to leave pretty soon.
Yeah, actually, I probably should leave. So I want to thank